talk about gases first. It's important to understand that gases are compressible, and the volume of gas can be made smaller. It's also important to understand that the molecules that make up gas will fill the space that they are in. Now let's move on to pressure. Pressure equals force over area. There's something called atmospheric pressure, which pushes down on us all the time. As a fun fact, your ears pop in an airplane because there's less atmospheric pressure at higher altitudes.
There are several gas laws that help us understand how gases work. The first person we're going to talk about is Robert Boyle, and from him we get Boyle's law. Boyle's law says that P times V equals a constant, or P1V1 equals P2V2. So in other words, it's saying if you have a decreasing volume, that will cause an increase in pressure, or the other way around.
The next person we're going to talk about is Jacques Charles, who came up with Charles's law. Charles's law states that volume over temperature equals a constant, or in other words, initial volume over initial temperature equals the final volume over the final temperature. What this means is that when you decrease the temperature, it'll cause a decrease in volume, and when you increase the temperature, it'll cause an increase in volume.
Now we're going to talk about Amedeo Avogadro, from where we get Avogadro's law, which says that volume over number of moles equals a constant, or V1 over N1 equals V2 over N2. So it's saying if the number of moles increases, the volume also increases.
Next, we're going to talk about the combined gas law, which combines a few of the different laws that we've already talked about. And it states that PV over T equals a constant, or the initial pressure times the initial volume over the initial temperature equals the final pressure times the final volume over the final temperature. It's important to know that you use this law when you're changing two variables.
The ideal gas law says that pressure times volume equals number of moles times a constant times temperature, where the constant is R and it equals 0.08206 liters times ATM over moles times kelvins. An ideal gas is a gas that obeys the ideal gas law.
Now it's time to review these laws with some example problems. The first problem has to do with Boyle's law, and it states, the volume of a stomp rocket pump changes from 1.03 liters to 0.47 liters when stomped on. If the internal pressure is 1.0 atm, what is the final pressure? In order to solve this problem, you need to use the equation initial pressure times initial volume equals final pressure times final volume. When you plug in these numbers, this is the answer you should get. This next example has to deal with Charles's law and states, the volume of a balloon at 25 degrees Celsius is 2.3 liters. What is the volume at 50.0 degrees Celsius, assuming the pressure is constant? In order to solve this problem, we first need to turn degrees Celsius into Kelvin. In order to do that, when you have degrees Celsius, you have to add the number 273.15. So we now know that 25 degrees Celsius is 298 Kelvin, whereas 50 degrees Celsius is 323 Kelvin. In order to solve the rest of this problem, we need to use the equation initial volume over initial temperature equals final volume over final temperature. When we plug in the numbers, this is the answer we get. Our next example is using Avogadro's law, and it states, a helium balloon containing 0.10 moles of gas occupies a volume of 2.4 liters at 25 degrees Celsius and 1 atm. How many moles have we added if we inflated it to 5.6 liters? In this problem, since the temperature and the pressure are constant, all we are worrying about here is the volume and the number of moles. So we use the equation initial volume over initial moles equals final volume over final moles, and we get that the final moles to be 0.23 moles. However, we want to know how many moles we've added. So in order to figure that out, we need to subtract the number of moles we started with from the final number of moles. When we do that, this is what we get.
Our next example is with the combined gas law. A 2.37 liter sample of a gas at 25 degrees Celsius and 1 atm is heated to 297 degrees Celsius and at the same time is compressed to a pressure of 10 atm. What is the final volume? So first we need to convert degrees Celsius into kelvins, which you guys can do on your own. Then we plug in the given values into the equation P1V1 over T1 equals P2V2 over T2, and this will give you your answer in liters.
The last example here involves the ideal gas law and asks, how many moles of helium gas are contained in a 10-liter cylinder at 25 degrees Celsius and 120 atm? In this experiment, again, you need to convert degrees Celsius into Kelvin, but I have confidence that you guys can do this. And we also need to know that the constant R equals 0.08206. So when you use PV equals nRT, this is the answer you will get.
For this experiment, we took 2 marshmallows and put them inside the syringe. Observe the marshmallows as pressure increases and decreases.
In this experiment, we blew up a balloon. Observe what happens as more moles are added to the balloon.
For this experiment, we added colored water to a plate. We then lit a candle and put a jar over it. Observe what happens when the flame goes out and the temperature decreases.
In this final experiment, we took a balloon, we measured the circumference of the balloon, and then we put it in a freezer that was -4 degrees Fahrenheit. When we initially measured the balloon before it was in the freezer, it was 26 inches. The next day, when the balloon was taken out of the freezer, the circumference was measured to be 25 inches. So the balloon lost 1 inch of its circumference.